For this video, we're going to look at secant and cosecant graphs. So our objective is to be able to graph secant and cosecant. The big idea we're going to look at with this video is we're going to look at the connection to the reciprocal functions. If you know how to graph sine and cosine, sine being the reciprocal of cosecant, cosine being the reciprocal of secant, then you can translate that into what this graph will look like for secant and cosecant. So first of all, our first idea is to draw a dotted graph of the reciprocal function. Next, what you want to do is draw the asymptotes where this reciprocal function crosses the midline. That idea is where it crosses the midline. If you think of that as the zero value, that midline, if you take the reciprocal of that, that's going to be an asymptote because that's undefined. Now, most of our midlines have been the x-axis. Later, or you may have already started doing this, we're going to translate sines and cosines and secants and cosecants up and down and side to side. But for now, whatever the midline is, where it crosses that, that's where your asymptote's going to show up. And then lastly, use the mins and maxes of the graph in order to start where the rest of the cosecant and secant graph go. So let's start with secant. We're going to graph the cosine graph as a dotted graph. That's our reciprocal function for this one. So when we look at cosine, we're going to first of all recognize that the amplitude is up to 1 and down to -1. And our period, I'm going to do period in both degrees and in radians. So our period goes out to 360 degrees or 2 pi. Halfway to that is 180 degrees or pi. Halfway to that is 90 degrees or pi over 2. And then halfway between those two, I'm going by 90s, so this will be 270 degrees. And then if I keep going by half pi's, this will be 3 pi over 2, or 1.5 pi. All right, so looking at our cosine graph, let's draw that first. Cosine graph starts at the amplitude, goes through the middle, goes to the bottom, goes through the middle, and goes up to the amplitude. So the graph of it, dotted, will look like this. Okay, so there's our dotted graph for cosine. Now the reason why we do a dotted is it influences our graph by thinking reciprocally, but it is not actually part of the graph. It's not an asymptote, it's just a guide for how to do, in this case, the secant graph. Now what we want to do then is take and draw the asymptotes where it crosses the axis. So here is one asymptote, here's another asymptote. That's because if we have 0 as a value, if you take the reciprocal of 0, you get undefined, which would result in an asymptote. Now, use the mins and maxes, like this max here. If this is going down, reciprocally, the secant will go up in value. Same's down here. From this minimum value, it goes up on both sides from there. So this is going to go down on both sides to think reciprocally. Okay, think about it. This is -1. -1 is its own reciprocal. Then if I go with, say, a -2 down, say a -1/2 here, its reciprocal would be -2, so it will go in the opposite direction. Then lastly here, this is reciprocal of 1 is 1, and then every other fraction of these, when you do its reciprocal, are going to make it go up to a larger number. So that's how you draw. This is what one period of secant looks like. If you put this one with this one, you'll get another curve. It's an up curve and a down curve for one full period. All right, let's do a cosecant. We're also going to draw the reciprocal function, which is sine. We'll do this one as dotted. So the dotted graph will go up to 1 and down to -1. And we go out to, this will go out to 360 or 2 pi, which halfway is 180. to pi, and 90 degrees, pi over 2, and then here 270 degrees, 3 pi over 2. So same key points as the cosine, just for the sine. Now we're going to draw sine as a dotted graph. That starts in the middle, goes to the top, through the middle, to the bottom, and then to the middle. So the dotted graph looks like this. Okay, so there's my dotted sine graph. Now that will influence what my cosecant graph looks like. Wherever it crosses the axis will be an asymptote. Now I usually don't have to draw it on the axis, but I'll just show that that's an asymptote because it's at 0. It'll also go through pi here. It's an asymptote, and then 2 pi. Now what we do next is we go ahead and use the mins and maxes. So this maximum here, it goes down from that here, so we're going to go reciprocally up. Same with this, down at the bottom here, it's going to go down because it goes in the reciprocal direction. So that's one period of my cosecant graph. All right, that's what the standard graphs look like. Let's go ahead and change on our reciprocal graphs. Let's change the amplitude. Now these graphs, notice, don't have any amplitude because they go off for forever, but we want to also on these use the sine and the cosine to influence our graph. So let's go ahead with this one. We're going to graph y equals 7 sine of 2x, which is the reciprocal. So my amplitude is up to 7. It goes down to -7. I'm going to do 2 periods in radians. So I'm going to start with 1 period. So my period is going to be influenced by that middle number, that 2. So I'm going to take 2 pi and divide by that 2. Remember, it works on the inside with the by dividing by it, the reciprocal direction on the inside. And so I get a period of pi for this. So I'm going to put pi somewhere in the middle because I want to be able to fit in 2 pi on my graph. So halfway to pi will be pi over 2. Halfway to that will be pi over 4. So I'm going by 4th pies, 1/4 pi, 2/4 pi, 3/4 pi, and then 4/4 pi. Now let's draw 1 period on this we're going to do 1 period of sine. So start in the middle, go to the top, go to the middle, go to the bottom, and then to the middle. So a dotted graph for this one. Now later you won't need to draw this graph because all we're interested in is where it crosses the axis and the min and max. So if you get those points from your just drawing those points, you don't have to actually put the dotted graph in, but we'll do it for now. Now wherever it crosses the axis, that's an asymptote. So here's my asymptotes for the graph. Okay, and then on this one we're going to go up, and then this one we're going to go down reciprocally. Now let's go ahead and complete our 2 periods. So we're going to go out to, here's 1 pi, let's go out to 2 pi. I'm going to split that in half and then these 2 in half. And so we're going by 1/4 pies for each of these. So this is 4/4, this would be 5/4 pi. This would be 6/4, or we reduce it down to 3 pi over 2. And then we've got 7/4 pi, and then 8/4 pi for the last one. All right, so now that's that part of the graph. Let's go ahead and draw our, let's draw in our sine graph. So we're at the middle, we go to the top, to the middle, to the bottom, down here, and to the middle. So just a graph like this. And now we're going to go ahead and draw in our other period of pi. So here's another asymptote where it crosses the axis, the midline, in this case, which is the axis. And then at the top point, reciprocally, this one goes down, so we're going to go up with the U, with a curve here, and then down with this one. So there's 1 period and 2 periods of my cosecant graph. All right, let's now look at the last one here with doing secant. So we'll do the same process of going, my amplitude of the reciprocal one is 3 and down to 3. So I'm going to be graphing y equals 3 cosine of 1/4 x with on this as a guide for my graph. So my period is going to equal 2 pi divided by this interior number, 1/4 on the inside. That's 2 pi times 4/1, which is equal to 8 pi. So I'm going to lay 8 pi out here. Halfway to that is 4 pi. Halfway to that is 2 pi. So it looks like I'm going by 2 pi's every unit. And it'll be 6 pi next. And keep going. If this is 8 pi, another period will take us out here to 16 pi. Split that in half and then these in half. So I'm going by 2 pi's. So this will be 10 pi, 12 pi, 14 pi, and then 16 pi for my final landing spot. So secant is going to be, the reciprocal function is cosine. So start at the top, go through the middle, go to the bottom, go through the middle, through the top, through the middle, through the bottom, through the middle, and then to the top. And so a dotted graph here for my reciprocal function of cosine looks like this. So we're also practicing our cosine and sine graphs by doing this. Now I take and I finalize my graph by wherever it crosses my midline, I draw an asymptote. So I get these asymptotes drawn, and then wherever I have a maximum, go inverse to it, go up. Minimum, go down to the reciprocal direction. Go up here from the maximum. This from this point goes up from that, so I'm going to go down reciprocally from it. And then lastly here, this one goes down from there, so I go up toward the asymptote. So how we draw secant and cosecant graphs is we first start with sine and cosine, draw those as a dotted graph to guide your graph. Then wherever the sine or cosine crosses the midline, draw an asymptote for it, and then use your mins and maxes to guide reciprocally. If the graph goes up, down from the maximum, then you go up from it on your secant or cosecant, or if it goes down from goes up from the minimum, you go down from it on the secant or cosecant. So that will mean that the reciprocal functions influence or help us draw the secant and the cosecant graphs.